Alright, so today we're going to finish up section 4.2. We're going to continue graphing these rational functions. It's real important today that you have a calculator or you go to desmos.com when we go to graph it. But anyways, this information here on the left is stuff we need to be able to find on our own. Okay, so starting with the x-intercept, same stuff we've been doing the past 2 days. Whenever we have an x-intercept, we're thinking numerator. Okay, so what we're going to do with our numerator is we are going to go ahead and take 3x minus 2. I'm going to do it down here in blue. So we got 3x minus 2 equal 0. Okay, so 3x minus 2 equals 0. And we go ahead and solve for x. So I go ahead and add 2 to each side. And then divide by 3. So we get x equals 2/3. Now, you need to make sure that you are writing this as an ordered pair. Okay, so my x-intercept, when I go ahead and do this, is going to go ahead and be 2/3, comma, 0. When we quiz or test, if you don't have it as an ordered pair, it's going to be wrong. From there, when we get a point, we got to go ahead and put it on here. So I got 2/3, 0, got it in blue. There we go. Next thing they ask us to find is y-intercept. Y-intercept you're absolutely going to have to do when we quiz. Y-intercept, I'm going to go ahead and do it in pink. For that, you plug in 0 for x. Okay, it's the same stuff we've been doing for the past few days. So with that, we can go ahead and do it in pink down here. Wherever I see an x, I'm going to plug in 0. So I got 3 times 0 minus 2. Over 0 squared plus 7 times 0 plus 12. Honestly, I didn't really even need to do that. Okay, all you gotta do when you're plugging in 0 is we cover up the x's and they're gone. So I'm gonna be left with y equaling negative 2 over 12, which is the same as negative 1/6. Okay, same deal as the x-intercept. You gotta make sure we write this as an ordered pair. So as an ordered pair, it would be 0, comma, negative 1/6. And as we get the points, we got to go ahead and put them on our graph. So we got 0, negative 1/6. Not perfect, but I'm going to put it right there. Okay, next, they want vertical asymptote. I'm going to do that in baby blue. Vertical asymptote is always the denominator. So we're going to go ahead and take our denominator of x squared plus 7x plus 12. I'm going to set that equal to 0. This goes back to what we've been doing all year long. You go ahead and factor that. So what multiplies to give me 12, yet adds to give me 7? It's going to be a positive 4 and a positive 3. After we have that factored down, we go ahead and break them apart. So I have my x plus 4 equals 0, x plus 3 equals 0, and we solve. So we're going to get vertical asymptotes at x equals a negative 4, x equals a negative 3. Remember, an asymptote is a line, so these are not points. They should be equations. Okay, so I got my vertical asymptotes of x equals negative 4, x equals negative 3. I'm going to go ahead and draw those in on my graph. So we go ahead and draw those with dotted lines. I'm going left 1, 2, 3, and there's my 4. So I got x equals negative 4, 2, 3, x equals negative 3. Okay, last thing we got to find here is our horizontal asymptote. If you remember back to when we did 4.1, we have 2 cases that we're going to deal with anyways. We have when the degrees are the same. So if the degrees are the same, you go ahead and divide the leading coefficients. In this case, though, the degree up top is greater. So since our degree up top, we'll say this degree numerator greater than degree denominator. Whenever that's the case, our horizontal asymptote right away is y equals 0. Y equals 0. Okay? So I go ahead and have a dotted line at y equals 0. Now, if you remember back to 4.1, I told you sometimes we come across like these weird graphs where the horizontal asymptote, we actually have points on it. And that's totally okay. They're weird, but they do occur. We will never have a point on the x or the vertical asymptotes though, okay? But y values can land on the horizontal asymptote. It's not the end of the world. Okay, so if our degree for the numerator is greater than, this should be less than the denominator, we go ahead and have a horizontal asymptote at y equals 0. Last thing we need is domain. Remember, your domain is always all real numbers, and then it is x cannot equal whatever our vertical asymptotes are. So in this case, I got a -4 and a -3. Okay, so that's all information you need to be able to find on your own. Okay, you just need to be able to do that. Probably the trickiest thing is the horizontal asymptote. Okay, so the horizontal asymptote, if the numerator, the degree, is less than the denominator. Okay, so degree numerator less than degree denominator, it is always going to be y equals 0. Always, always, always. Okay, if they are the same, so like if you look at example 4, which you're going to do on your own, in this case they're the same, remember you take your leading coefficients and divide them out. Okay, for the range, I went ahead and crossed it off. In this class, we're not going to worry about like the weird ranges. So like when we have a point on the horizontal asymptote, you will not be asked the range. Okay, the last thing we need to do here is go ahead and provide a graph. Okay, so you have two options here. If you have a graphing calculator, go ahead and use your graphing calculator. If you do not have a graphing calculator, what I need you to do is go to desmos.com. And hopefully this internet works. Okay, you go to desmos.com, gets you this screen right here, and then you click on graphing calculator. And it kicks you to this graphing calculator screen. So over here on the left, I'm going to go ahead and type in my function. The biggest thing you got to make sure of is that you have parentheses around both the numerator and denominator. So my numerator is 3x minus 2. You got parentheses around the whole thing. And then when we divide, we hit the backslash button. And then again, parenthesis, x. The way we get squared is the caret button, which is shift 6. And then to get out of that, we hit the right arrow. So I have x squared plus 7x plus, we're going with 12. Okay, so I want to make sure that like we have a full grasp on what's happening here. So you can zoom in and zoom out by scrolling. Okay, and there should be a portion of the graph in each of these sections. Okay. So like originally, like when I zoomed in, like we only had these two right here. If you zoom way out, we're going to have something in that middle section as well. So looking at this, it's just a rough sketch, okay? I have on the left-hand side, I'm going to try to do these at the same time. So let's go there, there. On the left-hand side, we're like right around like the 0. And then we are coming down. Okay, so I got my left-hand side taken care of. My middle, I got it like way up there at 50, but it's just a line going up in the middle. Okay, so it's somewhere like way the heck up there. And it's not a line, it's a parabola going up in the middle. And then for my right-hand side, we're coming up the asymptote. And then we are passing through this point, and then we're going right down it. Okay? So to make rough sketches for these graphs, you are going to go ahead and use either Desmos or your graphing calculator to do it. Honestly, the biggest thing here, especially for the quiz, is that you're able to answer the x-intercept, y-intercept, vertical, horizontal domain. Those you need to be able to answer on your own. Okay? Use Desmos to get a rough idea, but on the quiz, it won't be the end of the world. So I need you to go ahead and do example 4 as your try it. So you're going to do example 4 on your own, and then I need you to take a picture of that and turn it into Google Classroom for points.